Good morning. Okay, so today we're going to solve some multi-step equations. So some of the same rules apply as solving equations, but there's just a few more steps in them. So if you haven't done it already, do the minds on for 4.2 right now. Please pause the video. And okay, today's learning goal, by the end of the lesson today, you're going to be able to solve some equations that require a little more simplification before you solve, or they might require you to use the distributive law before you solve for the variable. All right, let's do that. Mine's on. So pretty straightforward. You're just going to add 7 to both sides to get rid of the minus 7, sorry, that's on this side of the equal sign. And you can do that on both sides. And some of you were asking yesterday, do I have to show this? And absolutely not. You can show it a different way, and I'll just go through that in a second. So this is 6x equals minus 6, and then we're going to divide through on both sides by 6, and we get that x equals negative 1. So another way that you could have done this is if you just think about moving that minus 7 to the other side, and when you move a number, the sign changes, right? When you move it across an equal sign. So this would be 6x equals minus 13, and instead of minus 7, we're going to put plus 7. And then the rest is the same, 6x equals minus 6, and then you're dividing both sides through by 6 and getting x equals negative 1. Okay, it did say to check, so we'll go ahead and check. So checking means you're writing 6x minus 7 equals negative 13, and you're subbing in for x equals 1. So 6 times negative 1 minus 7 equals negative 13. Is that true? Well, this is negative 6 minus 7. Lots of you weren't taking it fully down to left side equals right side, so you need to actually evaluate that, which is negative 13. And now that you have both numbers the same, you can say left side equals right side. Therefore, x equals negative 1 is the solution. Okay? Now, some of you are not following this process, and you are doing things like, let me just see. You're doing things like, oh, let me guess. What can I put in there? Oh, I'm pretty sure it's negative 1 that'll work. So you're doing something like this. 6 times negative 1 minus 7 equals 13. Negative 13. Well, that's true. But where's your variable? Right? What you have to be doing is in every step, you need to be trying to isolate for your variable and getting your x by itself at the end. That's the whole point in adding 7, is we're getting it down to 6x. Then we're dividing through by 6 to get it down to x. Okay, so if you're not showing me these steps, you're not doing it properly, and you're going to lose a lot of marks. Okay, this is not the solution. All right, so let's start on today's lesson. We're just going to go over the distributive property again. You were already doing that, I think, when we were simplifying expressions. So the distributive property is basically just telling you to multiply whatever's on the outside of the brackets inside the brackets. Now, in this case, what it did, used BEDMAS, and it multiplied, it added 3 and 2, which is 5, of course, and then it multiplied 4 times 5 to get 20. But in this example here, which is the same question, we took 4 times 3, which is 12, plus 4 times 2, which is 8, and we get the same answer, of course, 20. So it means then that a times b plus a times c is the same as this, right? All this is a times b plus a times c. All right. So let's just quickly do a few of those examples. Those are super fast. So this would be 3x plus 12. This one would be minus y plus 3. Do you want to just pause the video now and try these other last two and then see how you do? Okay, so if I have minus 5 times 3a, that's minus 15a. And if I have minus 5 times positive 2, that's going to be minus 10. I can't combine any of these, right, because this doesn't have an a attached. So let's see, this 6 gets multiplied just by what's inside the brackets. So that's just going to those two terms. It doesn't get multiplied here. We have a closing brackets. That's where it stops. So this is going to be 6x plus 12. And then this is going to be plus 2 times 3x and plus 2 times plus 1. So this is going to be plus 6x plus 2. So then we end up with 6x plus 6x, which is just 12x, and plus 14. Okay? All right. So, probably put equal signs everywhere. So that's expanding and simplifying. But that's not solving, right? So that's just part of solving. So the steps for solving equations are to eliminate the brackets using the distributive law if you have to. And then you're going to isolate just like we did yesterday. So you're going to start by isolating the additions, right? You're going to get rid of the additions or the subtractions first, and then you're going to get rid of any divisions or multiplications. So let's start with the first one. We've got 2 times x plus 2 times 3, which is 6, equals 14. All right, well that wasn't too bad. And now I need, if I want to get x by itself, I've got to move this 6 to the other side. So this is going to be 2x plus 6, and then I'm going to continue to do the minus 6 thing. And again, you don't have to. You can just show it as moving that 6 over and it becoming negative. All right, so then we've got this cancels out. We're left with 2x equals 8. And we're going to divide both sides through by 2 and get x equals 4. Okay? Not too difficult. All right, this one, again, nothing happening on the left-hand side. I can't combine those two. One's an m and one's a number. So I can't really do anything over here, but I do see on the right-hand side that I can distribute that minus 3 into the brackets. So that's what I'm going to start doing. So I have to still write 9m minus 4 equals, and then I'm going to end up with minus 6m plus 21. So now we need to get the m's on the left side and we need to get the numbers on the right side. And you can do that by a couple of steps. So if I want to add 4 to both sides, that's going to get me no minus 4 on this side, right? So I'm adding 4 to both sides of this equation, and I end up with 9m only over here. So that's good. And now I end up on this side with minus 6m plus 25. So I still have to deal with this minus 6m over here. So what I want to do is I want to bring it to this side. I can think about moving it over the equal sign and changing this to a positive, or I can think about balancing the equation by adding 6m to both sides. So this is going to be 6m plus 9m equals minus 6m. And I can do the plus 6m here. It doesn't matter where you do it. Plus 25. So minus 6m plus 6m, that's gone, and we're just left with 25. And this is 15m. So 15m equals 25. And when I get m by itself, I'm going to divide through both sides by 15. And I end up with m equals, this is just a fraction. It doesn't come out to a whole number, so I'm going to leave it as in fraction form, but I'm going to reduce it. 5 goes into the top and the bottom. So this is going to be 5, excuse me, thirds. Okay, it's okay, excuse me. It's okay if it's a fraction. Okay, so just to, another point to go over, you notice that in every line I still have a variable, right? I haven't figured out what my answer is. I wouldn't have been able to guess what my answer was up here. So that would have been too hard. So this is how you have to do it. You have to isolate for your variable, okay? All right, let's keep going. So this side, we're just going to apply the distributive law. So this is 3a plus 9 plus 4a plus 7. I don't have to simplify that. Equals 5a minus 2. So that's all I did in the first step, was just to get rid of these brackets. Sorry, I shouldn't have put that equal sign there. Let me just get rid of it. Okay, so 3a times, yeah, okay, got it. 3a plus 9 plus 4a plus 7 equals 5a minus 2. And now I'm just going to combine everything on this side. So I have a 3a and a 4a, so that's a 7a. I have a 9 plus a 7, that's plus 16, equals 5a minus 2. So let's get the a's on this side and the numbers on this side, which means I have to get rid of the number on this side. So I'm going to write 7a plus 16 minus 16 equals 5a minus 2 minus 16. And that simplifies, oh shoot, that should have been in red. Alright, and so that simplifies down to 7a equals 5a minus 18. And now I need to get rid of the 5a on both sides. So I'm going to end up with 7a minus 5a equals 5a minus 5a minus 18. So let's see what we end up with. 7a minus 5a, well that's just 2a. And these cancel and we're left with minus 18. And then I'm going to divide both sides through by 2 to get a all by itself. So this is a equals negative 9. Now, that was a lot of steps. I'm probably going to check that one just to make sure. So I'm just going to come up here. I'm going to check it by substituting in negative 9 to my original equation. So you can see I just substituted in negative 9 wherever there was an a. And then this is going to be 3 times negative 6 minus 36. 4 times negative 9 is minus 36 plus 7 equals negative 45 minus 2. So this is minus 18 minus 36 plus 7 is equal to minus 47. I see that. So minus 18 minus 36 is minus 54, and minus 54 plus 7 is minus 47. So I'm comfortable with this answer then, but I wasn't really at first because there were so many steps. Okay, so this one is a lot like one that you did yesterday. So what's happening here is you are either you're doing two things. You've multiplied the a times 5 and then you've divided it by 3. Or you can think about the fact that you've multiplied a by negative 5/3. Okay, so up to you how you want to approach this. Whoopsie. I would say I might multiply through by 3 first. So let's go ahead and do that on both sides. So we'll have 3 bracket minus 5a over 3 equals 3 bracket 1. Okay, so this ends up canceling and we end up with minus 5a equals 3. And then to get a by itself at this point we just need to divide through by negative 5. And so a, these cancel and you're just left with a here equals 3 over negative 5, or you can put the negative out in front. It doesn't really matter, okay? But this fraction is negative. All right, let's keep going here. So we've got k minus 1 over 2. So the whole numerator is being divided by 2. So you must do that. So what happened to the k was you subtracted 1 and then you divided by 2. So the opposite of that would be to multiply by 2 first, and then you're going to add whatever number. So this is going to be 2 times k minus 1 over 2 is equal to 2 times negative 5. So now we can cancel those, and we're left with just k minus 1 equals negative 10, and then you're going to just add 1 to both sides to get rid of the negative 1 on this side. Okay, so this becomes k equals negative 9. Okay, that's tricky. Definitely tricky. So this one, what happened to the x was we added 3 and then we multiplied it through by 2/3. And so for this one, you're going to undo that by undoing the 2/3 first and then subtracting the adding of the 3. So we would multiply this. I think the easiest way to do this is probably actually to divide both sides by 2/3. So I'll just write it out. So this is 2/3 times, there's a few different ways you can do this. This one's a little bit confusing. So if I divide by 2/3, I'm going to do that on both sides. If I divide this whole thing by 2/3, I'm just canceling the 2/3, and I would just have x plus 3. So that's kind of nice. And then 4 divided by 2/3, if you do that on your calculator, 4 divided by 2/3, that's the same as saying 4 times the reciprocal, which is 3 over 2. And this is just tops by tops, bottoms by bottoms. So this would be 12 over 2, which is just 6. Okay? So you can do that on your calculator, however, and it'll be a lot easier. So x plus 3 equals 6. And then you're just going to proceed to getting rid of the 3 on that side by subtracting both sides by 3. Okay, so this is going to be x equals 3 is our final answer. Okay, I know that's tricky. Why don't you go ahead and try G and see if you get it right. Just pause the video. Okay, so I can see that y is being multiplied by 2 and divided by 7. So I could do the opposite operations, which means I would multiply both sides through by 7 and then divide both sides through by 2. Or I could do it in one step by just taking negative 10 and dividing it by this coefficient. It's a fraction, but big deal. This is 2/7. 2/7. Okay, so I'm dividing this whole thing by 2/7. So this ends up canceling, and I'm left with just y over here. And then this is negative 70 over 2, which is negative 35. So do it on your calculator. Negative 10 divided by 2 over 7 is the same as negative 10 times 7 over 2. We flip it and we change it to multiplication. And this is negative 70 on the top and 2 on the bottom, which is just negative 35. Okay. Last but not least. Okay. Scott makes $800 a month working at a grocery store. The store also gives him a 0.5% bonus for every hour he works in the month. His pay is represented by the equation A equals 800 plus 0.005 times 800 times n, where A is the total amount that Scott earns and n is the number of hours he works in the month. All right, what will Scott's earnings be if he works 160 hours this month? So this is his bonus here. He gets he gets a 0.5% bonus on his earnings. So there's his $800, but then this is his bonus of 0.5%. Remember, you divide by 100 in order to get this in decimal form. So 0.5 divided by 100 is 0.005. And then we're going to multiply that by the 800, and then multiply that by the number of extra hours that he actually works. Not extra hours, but the total number of hours that he works. Okay, so he works 160 hours. He's going to get the $800 for sure, because that's what he always gets, no matter how many hours he works. And then he's going to get, so that's that. He's going to get his bonus of 0.5% of his 800 times 160 hours. All right, so really, this is just calculator work. You can just take 800.005 times 800. I'm just going to do that in the calculator. That's 4 times 160. So he gets an extra $4 for every hour that he works. That's pretty nice. So he's going to get 4 times 160 extra dollars. So $640. That's pretty sweet. So he gets this is his total amount. It's 800 plus 640. A is 1440. His earnings will be $1,440. What will his earnings be at the end of the month if he worked 100 hours? So we're going to just sub those numbers into the same equation. This time, we still know that this is just 4, so I don't really need to put this in again, and it's going to be 100 instead of 160. So 800 plus 400, oopsie, looks like he's making $1,200. So his earnings will be $1,200. Include the, actually we should probably include the cents and include the $sign for sure. If Scott wants to make $1,760 at the end of the month, let's say he has a car payment or something and he needs that money, how many hours would he have to work? Okay, so this time we know what our A is. We know our total amount is $1,760. He's still only making $800, but he's got that bonus of $4 for every hour that he works, right? So I'm just going to leave that as H. No, sorry, it should be N. I didn't realize. Let me just go back and change that. So we've got it written as N for the number of hours that he works. So that's going to be N. And now I'm just going to move that. I'm trying to isolate for my N. That's what I'm trying to solve for. So I'm going to move that 800 to the other side by subtracting 800 from both sides. So that gets rid of the 800 on my right hand side. So now I just have 4N, and this is 960. And then I'm going to divide both sides through by 4 in order to get N by itself. So I have N equals, let's see, 4 goes into 9 2 times, looks like $240. It's not dollars, what am I saying? What is it? It's hours. So therefore, he would have to work 240 hours to earn $1,760. I know that doesn't look very good. $1,760. Okay, I do believe that is all she wrote. So what I want you to do now is you consolidate for 4.2 and put it on my desk, and then start on your textbook work for section 4.2. I'll write those questions on the board. Okay, thanks.